Yeah, I'm Derek, CTO here at WalletConnect. And first of all, I want to say I'm so excited about WalletCon because I think it's, to me, the inflection point of when crypto finally takes the end user experience really serious. And I'm so excited that everybody who has a stake in that, all stakeholders are in the room. And I'm going to talk about one little piece and then one little improvement about the end user experience in the security space. So first of all, I'm German. So I'm very credentialed to talk about Angst, which for the non-Germanophones of you means fear. It's probably related epistemology-wise to anxiety. I'm not sure about that. I'll let you do the research. But I think for all of us, Angst and anxiety, cryptos with security is somewhat of an intimate subject because we are coiners. We all know the fears, the various fears that we may have, that we get hacked. And the attack vectors in crypto are so vast. So you might lose your private key, like you might write down your seed phrase somewhere where you shouldn't, and you might lose your private key. You might get hacked. The smart contract might get hacked. So it's like a plethora of attack vectors. And if we want to get to the first billion users, then we're not going to get there unless we improve security, because it's a really important part of the end user experience. One of the mental models that you hear quite a lot is it's 1995 basically for crypto. So the end user experience is akin to having a dial-up modem, and security is one important piece of that. Currently, for instance, if I sign a gasless transaction, it shows me some binary blob, and I'm already super scared of what I'm actually doing. And for instance, my mom or my sister actually works in crypto, is super scared when they see things like that. And even me myself as an engineer, when I see a transaction blob, I have no idea what's going on. So just to motivate the problem a bit. And what I find really fascinating is that previously in pre-crypto and in the Microsoft Windows times, there was actually an entire industry dedicated to exploiting users' anxiety. So antivirus, for instance, was complete vaporware, but people would pay for it just because they would have a slight sense of that they would be more secure, versus in reality, often antivirus would actually do the opposite. So they would introduce new attack vectors. So I just find it really interesting that this even existed. And then it took a paradigm shift to get rid of antivirus, and to nowadays we're not as scared anymore that our computer gets hacked, or at least there's no vaporware industry around it anymore. And one thing I want to point out is that the inception of the App Store, or in the iPhone, it was actually really simple ideas that ushered in this new era of trust on the iPhone and also on Android. So the simple ideas were just a sandbox programming model that as a developer, I don't have as many permissions of bad things that I can carry out. That was one thing. So it's a really naive idea. It's not rocket science. And another thing was the App Store. So basically you go through a review process, and there's a way of penalizing you if you violate those rules. There's of course also a lot of problems right now with the App Store that we can agree on, but the idea really ushered in a new era and was great for the end user. And again, it was really simple ideas. Another thing I want to highlight is trust in the internet wasn't a given thing. When Bozo created Amazon and decided to do a bookstore online, one of the big questions was, would people even feel comfortable using a credit card online? Today it's normal for us, but it definitely wasn't normal. And some of the small innovations that brought us there and brought us this trust was, for instance, in eBay, where they started using PayPal. And again, it was really low-hanging fruit idea of having a dispute mechanism and speeding up, of course, also the transaction process. But having a trusted dispute mechanism was really not rocket science, really small idea that enabled us to have online payments. One thing that's going to be hard on this road, again, to get to 1 billion users, is media and also ourselves are very excited about all the scams and whatever that's going on in crypto. And often for end users, it's also really hard to understand, was this a security issue, like FTX? Like, is this a crypto issue or is this another issue? Like, it's all bucketed into the same crypto thing. And then as the end user, I'm just scared and it's hard to untangle what's actually going on. Like, and obviously in the case of FTX, it wasn't a crypto issue, it was a bankster issue, basically. It was the old days. And what's really fascinating is in payments right now, like we use payments every day, we use credit cards. Here in the United States, you just give, in a restaurant, you just give the server your credit card. That's akin to giving someone your private key. It's completely crazy. Like they only need to, you know, take a picture or write down your card number and Google you to find out what your zip code is. And now they have your private key. They can carry out transactions on your behalf. And then there's an entire industry dedicated to like combating this fraud, both from the end consumer side and on the merchant side as well. And it's very costly. And it's just completely crazy that this still exists in the same way. For me, the most ironic thing in payments, and I use at Venmo, I used to work at Venmo, where we like integrated with Amazon and other merchants. For me, the most ironic thing is the secure payment terminal, like here to the bottom right, where I like basically swipe my credit card and I trust this thing. But like it's not secure, I can't trust it. Like what's the root of trust? So I think the entire payments industry is very, it's kind of ironic. And of course, a lot of players are trying to improve it. But I think maybe also crypto like can really shine, because when I use Trust Wallet, for instance, and I scan a QR code to pay, I can actually exactly see like what am I doing with transaction simulation and whatnot. So you're actually speaking about Trust Wallet. Here's what I mentioned earlier. This is a gasless transaction. So if someone can tell me what's happening here, then like I know what's happening here, but I think probably most of the coiners here in the room don't know. And this is not really criticism. It's just like a observation of the status quo today. Many people who are here at the conference today are addressing this through transaction simulation and whatnot. So it's going to get much better, but this is just the status quo as of today. So let's talk about domain binding and how hopefully it's going to make it better. So domain binding is also it's a super simple idea, and that I hope is going to like usher in a new paradigm or like a lot of new improvements. So basically, here you can see a sign-in, or like this doesn't exist yet. This is a screenshot from a beta version of MetaMask in the browser of sign-in with Ethereum. So as a recap, sign-in with Ethereum allows you to log in or sign up with a centralized website, and then through the sign-in with Ethereum protocol, it's only one step. It's not connect wallet, then sign, it's only one step. And on the server side, you can recover the public key of the address, private key that signed the message, so you can log in. And as part of the sign-in with Ethereum standard, which is really important standard because it improves the UX significantly, as part of the standard, you pass the URL, and then MetaMask in this case can show, hey, you're trying to log into uniswap.com, but you're actually on eviluniswap.com. So you can just flag this. And then the end user's going to be like, okay, maybe I double check something. So it's a really simple idea. And what I want to point out is that if you use MetaMask desktop or Trust desktop, then this is very easy to do because you're running in the same environment as you are when you're running as the wallet. So wallet and dApp are exactly in the same environment in the browser. So this gets actually really hard if that is no longer the case. But then, of course, now WalletConnect Verify API that Gancho is the lead developer on to the rescue. So what's Verify API? Basically, it's domain binding, but it's cross-platform. So it's not only in desktop wallets, it's everywhere. So that means it's web dApps, like a desktop website or a mobile website, but it's also a native dApp on Android and iOS and other platforms, which I think this year we're going to see a lot more native dApps coming online, which again is ultra important to get the next billion users because they're going to be on mobile, they're not going to be on desktop. So this is our internal prototype. To the left, you can see our sample wallet, and you can see the little verified thing. And to the right, you can see our sample dApp. This is not just for sign-in with Ethereum. It's like for all kinds of transactions, which is also really important. And yeah, here's a quick recap of how this works. So it's bulletproof on Android and iOS through like the centralized services that they come with. Android's Integrity API and iOS's App Attestation Service. On the web, it's not fully bulletproof, and I want to drill a bit into some of the challenges around that. But before, I want to say, like, why could this be a big deal? Why is this super simple idea of domain binding, why could it be such a big deal? And that's because if I have the domain, I can cross-reference it. Like the easiest thing is you just leverage a set of already known, like MetaMask and others. They curate a list of bad domains, basically, like eviluniswap.com. So the most naive thing is you just cross-reference, hey, is eviluniswap.com on any of these deny-listed lists, and then you would flag it to the end user. Then the next step would be you use something a bit more sophisticated, and there's various folks who do that. So basically a mapping from domain to contracts that are associated to this domain and like basically approved for this domain. So there's some crowdsourced approaches for this. There's some machine learning approaches for this. It's actually not so much of an easy problem, but we're gonna get there soon as well. So a really easy thing. And then I can highlight, hey, maybe like this contract that you're interacting with is evil Uniswap and probably you don't want to interact with it. And then going further, just once you already do this and on Trust or another wallet, you show like a little widget, hey, this is secure or not, then you can also enrich that with other things, like for instance, transaction simulation, which might be expensive and whatnot. So, but I think these two little ideas already buy us a lot. I want to go briefly into some of the challenges, why this is hard on web, why this has not been done before. And we worked with the Chrome team, the Brave team, OpenSea and Spruce on like, you know, how legit is our solution actually. And our solution is not super legit, but it's like 80% legit. And if you enrich it with these other things, it's like legit enough, we think, to be good. So, but a quick recap how the WalletConnect protocol works. So basically you have a wallet and a dApp that are both connected to a WebSocket server. And then browsers by default, let's say you're on uniswap.com as a dApp, browsers by default, when they connect to walletconnect.com, present an origin header that would say uniswap.com. So in the most naive way, you could just say, okay, this is coming from uniswap.com. However, the attack vector is super easy. You could just fish an end user to eviluniswap.com, spin up a proxy server that's also eviluniswap.com, and then that proxy server spoofs and manipulates this origin header, and WalletConnect can't discern anymore whether you're coming from eviluniswap.com or uniswap.com. And this is our solution for it. So we have like this fancy word of the WalletConnect browser enclave. So we're going to ship that optionally with our JavaScript SDK, and it like overcomplicates things quite a bit. For wallets, it's always the same API. They can verify, they already use our relay server, and they're going to be able to use our verify server to like check, hey, what's the origin of this transaction, or of this thing that I want to sign. And then on the browser side, we already have a JavaScript SDK that's like shipping with like everything, all the web dApps that use WalletConnect. And then we're going to embed a hidden iframe in there and use DNS verification and a couple of other things, CSRF tokens to establish a connection to the verify server. And then when on the dApp side, when you sign a message, it's sent fully encrypted over the relay server, over the WebSocket, and the dApp, which also has the unencrypted message, is going to do a hash over it and send the hash up to through the enclave up to the verify server. So that's how it works on the web. On Android and iOS. So again, on the web, it's not bulletproof, but good enough. Like you have to be a really sophisticated attacker. Also, you don't get any funds. Like you only get like this check mark that you can spoof. So yeah, you have to be a really sophisticated attacker and really motivated. And Android and iOS, it's going to be bulletproof. So that's really nice. And we have some cool launch partners lined up. And on the timeline, so we're ready, and we're looking for launch partners on the wallet side and on the dApp side as well. And over the next couple of months, we're going to be rolling this out. And what I'm really excited about is like some of the outlook and future work, like what's next in general in browser authentication and web authentication and wallet UX, what kind of standards are coming. So the first thing I want to highlight is WebAuthn and passkeys. So the difference is WebAuthn is a standard pushed by the FIDO Alliance. And the goal of both of this is to get rid of passwords. So that's the design goal of this initiative. But there's some side effects that we as a crypto industry can also leverage. So one of the side effects is that as part of the standard, the origin is like a core part of this. So the browser, in this case, the browser trust, signs the origin and sends it over. So we can use the chain of trust of like certificate authorities. And that's not perfect, but like well established with TLS and whatever, to verify the origin and potentially also a couple of more things. But this would solve this domain binding problem in a like 100% bulletproof way on the web. The problem is end users aren't really used to this UI yet. And also there might be an extra step, so it might slow down the connect wallet button quite a bit. So I think it's a bit too early, but we're like following this and also like collaborating with some other folks on this. The other thing I want to point out that you may not have heard about yet is FedCM. The design goal, like this is also a standard, a new web standard. The design goal of FedCM is a bit different. So the design goal is, the motivation was Apple, you may remember, overnight removed third-party cookies. And third-party cookies were used for a couple of bad things like fingerprinting and ad tracking, but they were also enabled also a couple of good things like small UX things that are important. So for instance, when you go to a website that you've never been before and you choose a Google OAuth login, through these third-party cookies, it can fill in your email address already. So it feels a bit more familiar, and now you only put in your password. So it's a small UX thing that doesn't work anymore on Safari because Apple killed the third-party cookies. On Chrome it still works. Chrome is going to follow Safari's lead or Apple's lead though, also remove it. So that was the motivation to like do something new, do FedCM. And here the idea is to pull the login away from the DOM, away from the like app-specific, website-specific level up into the browser. So then the idea would be I log in once, I do a sign-in with Ethereum with my Trust Wallet gated private key once, and then it's available on all browser tabs. Or like you do a Google login once and it's available on all browser tabs. And then you could be automatically connected to your wallet more or less, and it would be a standardized UI on the website to present this, which would also usher in a couple of other UX improvements in the crypto space. And that's it.
When you're looking at the domains, the certificate authorities, are you looking typically at Web3 domains, or are you looking at Web2 domains as well? And what kind of service are you using there?
Yeah, so we're rolling this out with just DNS verification. So you're on uniswap.com, and we're going to verify that you actually own uniswap.com. So this is a centralized service that we're adding. And we're starting with like just DNS, but obviously we want to like later support ENS and other things, and also further centralize our own service. We have no motivation of like being centralized.
I had a question around the allow list or deny list. Who creates the deny list?
Yeah, so there's a couple of deny lists, and you would have to aggregate them. And then there's curated deny lists, like MetaMask, I think, has one. Other folks have one too. But then and then there's a really innovative approach by Claros, who does like their prediction market. And basically they have the idea that you can say this is so there's some crowdsourced approaches too. But I think if you want to make this successful, for instance, this is a wallet, then you would have to like aggregate a couple of data sources. It's maybe something that WalletConnect could build, but we're building a lot.
That's very true. I have another question as well. You mentioned that right now the solution that WalletConnect has is about 80% legit, and we still need a couple of other pieces to reach that full 100%. What are we missing, and what do we have right now?
Yeah, so our take is, and like basically we aligned on this with like browser experts too. Our take is we're like 80% there. It's really hard to like break this, but then wallets should add more things like the domain check, for instance. Like the wallet now through this work has the domain, and the wallet already has the contract that you're signing against if you're signing a transaction against the contract. So you have those two pieces, and now you could check, hey, what are the allow listed domains for this contract, and now you can cross-check. So that would make it like really hard to attack and pretty bulletproof. And so we think like if you add these things together and enrich it, then it gets pretty bulletproof. But for the domain binding itself on the web, so there's only a problem on the web. On the web to be fully bulletproof, we'd need something like the passkeys or the WebAuthn, where the origin is signed by the browser CA and that we can then trust. But that's like probably a year or two out earliest.
I see. Cool.